So in this lesson, we're going to be going over adding and subtracting polynomials. This is going to be something important that you do from now until you graduate high school. You're going to have to do it some in geometry. They'll hit on some of those algebra concepts. You have to do it in Algebra 1, and you'll definitely have to do it in Algebra 2. Okay, so before we start, I want to talk about the standard. And I want to start doing clear learning targets. So it just so happens that the standard is pretty clear. It's not always going to be clear, so I'll have to break it down into a pretty clear learning target. But in this case, you're going to add, subtract, and multiply polynomials, and you're going to learn what polynomials means. Okay, so if you're not sure what that term means, we're going to go over that in this lesson. Okay, so you've got the first definition that we're going to talk about is monomial, which is a number, variable, or product of a number, and one or more variables with whole number exponents. So if you take a look here, I've got 4 terms, and each one of these is a monomial as long as it's alone, okay? So mono means one, so one term, okay? So I've got 10. 10 is a monomial. X alone is a monomial. 10x is a monomial, even though there's a number with it. And then 10x to the 5th is also a monomial, okay? And each one of these has a power, and if you take a look, if x is standalone, then it's to the first power. Oop, that was rainbow. If there is no variable, if there's just a constant, just some number, then the power is understood to be 0, so x to the 0. And then this one is x to the 5th, so the power is understood to be 5. Notice that they're whole numbers. I want to make sure that you guys understand if you see x to the 1/2 or to some fraction, like x to the 3/2 or x to the 5/6, that is not a monomial, okay? Because it's raised to a fraction of a power. So you can't have fractions. You can't have x to the pi, irrational numbers. So that's not going to work. And then also, that's not a monomial is what I mean. And you can't have negative powers. So x to the -2 means something completely different. It's not a monomial, okay? The degree of a monomial is the sum of the exponents of the variable, okay? So in this case, I've got 5x cubed. The degree is 3. It's the power. If I've got 2 terms next to each other, x squared and y cubed, it's the sum of those two. So 2 plus 3 is 5, so it's a 5th degree polynomial. A polynomial is a monomial, or sum of monomials, and each monomial is called a term. Okay? So down here is an example. I've got subtraction and addition going on between terms. This is x to the 1st, so that's a 1st degree term. I've got 7, so that's a 0, x to the 0 term. That's x squared, 3x squared, so 2nd degree term and a 4th degree term. So if I want to know the degree of any polynomial, I've got this polynomial up here as an example. It's the greatest degree of its terms. So if you take a look here, the highest power is going to be 4. So even if 7 is larger than this coefficient here, you're looking at the power. So this 1 doesn't work, x to the 0 isn't largest, 2 isn't largest, so this is a 4th degree polynomial because of that power. Standard form of a polynomial is a polynomial whose terms are summed from greatest to least. Okay? So here's our first example. I've got 4 minus 3x plus 2x squared, and I want to put this in standard form. So the first thing we're going to do before we put it in standard form is figure out the degree. Okay? So the degree is the highest power. So I've got x to the 1st, x to the 0, and x to the 2nd. Okay? So this is a degree 2 polynomial. It has 3 terms, 1, 2, 3. And then in standard form, it's going to be written from highest power to least power. So I've got 2x squared minus 3x plus 4. Okay? That is the standard form of that quadratic, or that polynomial. So 2nd degree polynomials are called quadratics. Over here, even though I've got a different variable, same thing going on, so that's y. The highest degree, highest power is 5, so this is a degree 5, a 5th degree polynomial. Number of terms, 1, 2, 3, 4, so still 4 terms. And then standard form would be highest power to lowest power, so I'm going to do 3y to the 5th, 8y cubed. Notice that 4 is negative, so that's going to have to be negative here, so negative 4y and plus 10, okay? And the reason why the constant goes last is because it's considered to be y to the 0 power, okay? So even if there's no variable beside it, it's the lowest term, okay? Easiest way to keep it straight. You'll see some different terminology in questions and in situations. So monomial means one term. So 3x to the 5th, that would be an example. I gave a few more examples, but I guess I'd give another one. I could have 2x squared y cubed. That is also one term, right? They're all being multiplied, so they're all together in one term. So that is one term. That is a monomial. Binomials are two terms, added or subtracted together, okay? So I've got 3x to the 5th plus 7. That's a binomial, two terms. Bi means two in this case. And then x minus 4, that is also a binomial. Some of the most common binomials are going to be linear expressions. Trinomial is three terms. So if you have three terms, like down here, 4y to the 5th plus 3y squared plus 7y, that is a trinomial. The most common trinomials that you'll probably see are going to be quadratics. So right there, x squared plus 5x plus 3, that is a trinomial, okay? So three terms. And then here is the meat of what we're trying to get into here, okay? So I've got 9x plus 7 minus 4y minus 5. So anytime you see an expression like this with parentheses around it, it's wanting you to use the distributive property. So I've got, oh yeah, this one, sorry. I've got a 1 here and a 1 there. So I'm going to distribute 1 and then break the parentheses. So 1 times 9x and 1 times 7, that's just going to be 9x plus 7. And then 1 times 4x and 1 times negative 10, I get 4x minus 10. So 9x plus 4x is going to be 13x. 7 minus 10 is going to be negative 3. Okay? Over here, something very similar. And you are done adding your polynomials when you can combine no more like terms. So combining like terms here, I only had 2 linear terms and 2 constant terms. So I'm finished whenever I get all the x's collected and all the constant terms collected. Or whatever degree is your highest, that's the ones you want to collect. So in this case over here, I'm trying to collect all these terms, but first I'm going to distribute this 1. And there's a reason why I'm showing you this. So I'm going to distribute that 1. 1 times 3w cubed is 3w cubed. 1 times negative 3 is going to be negative 3w squared. So 1 times negative 3w squared. 1 times 7 is going to be 7 plus 1 distributes here, there, and there. So distributive property. And I've got w cubed plus 5w squared plus 2w minus 4. So now what I want to do is collect all my like terms. So 3w cubed is a like term with w cubed over here. So 3w cubed plus w cubed is 4w cubed. Negative 3w squared has no other like terms. So I'm just going to bring him down, and there's nothing to collect with that, so I'm finished with square terms. So then I want to collect linear terms. Oh no, there is a, sorry, that was wrong. I've got negative 3w squared and 5w squared, so I'm going to collect those. So I've got 5 plus a negative 3, so that's the same as 5 minus 3, so plus 2w squared. Then I've got plus 2w. So 2w is the term that doesn't have anything with it. So there's no other linear terms or w to the first terms. So I'm just going to bring him down. And then 7 minus 4 is going to be 3. And once I've collected all like terms, that is it. That is all I have to do. So I've added all these polynomials, and I'm finished, so I'm good to go. Down here, it's very important to distribute here, because I've got a 1 here, so I'm going to distribute the 1. And in front of this parentheses, I've got a -1. And this is why I'm asking you to distribute, just to make sure. That -1 is going to have to distribute. Otherwise, the problem will be wrong. If you forget to distribute this -1, it can mess the entire problem up. So I've got -1 times 4. So I've got -4y. -1 times -5 is +5. And then over here, I've got 12y plus 7. And what that did is switch all the signs inside this parentheses. Anytime you multiply by a -1 towards a parentheses, it's going to switch all the signs. So then you can combine like terms. So 12y minus 4y is going to be 8y. And then 7 plus 5 is going to be 12. So 8y plus 12 is what they came out to be. So just make sure to distribute negatives whenever you see them. And then over here we've got this one. So I've got a 1 out front here and a -1 out front there. So the 1 distributes. So I get 3a squared minus 2a plus 7. And over here I've got a -1. So we're going to see something similar to the last one, but it's going to distribute to every term. So I've got to keep that straight. So -1 times 5a squared is -5a squared. -1 times 2a is -2a. -1 times -4 is +4. So now what I can do is combine like terms. So I've got 3a squared minus 5a squared. So 3 minus 5 is going to be -2a squared. And then I've got -2a minus 2a. So that's going to be -4a. And then 7 plus 4 is going to be 11. So you're just combining the like terms, which is just adding the terms. So I'm adding the coefficients. So -2 plus -2 is -4. 3 plus -5 is -2. 7 plus 4 is 11. So adding coefficients. And then we've got some more down here to do. So I'm going to go ahead and do those and end this video. So 1 distributes, that's just going to be the same thing. And then I've got a -3 to distribute, so that's going to be a little different. -3 times 4 is -12x. -3 times -10 is +30. 5x minus 12x is -7x. 7 plus 30 is 37. And then over here, there's only positive ones to distribute. So I'm just going to get the same thing with the parentheses broken and a plus sign between. So I've got 2b squared minus 5b minus 7 plus b squared minus b minus 4. So anytime you see a -b, the number in front is understood to be a 1, so that's -1. So I've got 2b squared plus 1b squared, so that's going to be 3b squared. -5b minus 1b is going to be -6b. And then -7 minus 4 is going to be -11. Okay? And I'm finished. I can write equals. So each line is equal to the last. And then here, I've got a 3 to distribute right off the bat and a 1 to distribute over here. So when I distribute that 1, I'm just going to get the same thing. It's a negative. If it's a negative, you're going to have a bad day. Not really, just make sure to keep it straight. So 3 times 2c squared is going to be 6c squared. 3 times 5c is going to be 15c. So I've got 6c squared is a like term with 5c squared. But I want to write this in standard form, so I'm going to do it from highest power to lowest power. 4c cubed is right here, so I'm going to bring 4c cubed down first, and then I'm going to add these two. So I want to list this in highest power to lowest power. So I've got 6 plus 5, which is 11c squared. And then I've got nothing to combine with 15c, so I'm going to bring that down. So 15c is finished. And then negative 10. And so what I like to do sometimes is if I have way too many terms, is I'll cross things out. So cross out 4c cubed, those two, just to keep that straight. There's nothing to combine, so just bring those two down and we're finished. And then here, there's a negative 1 in here, so make sure to distribute that. This one I can just bring down, so I've got 7n to the 4th minus 3n squared plus 2, and then negative 1 distributes. So I've got negative 1n to the 4th, negative 1 times negative 2 is positive 2n squared, negative 1 times negative 5 is positive 5. So I've got 7n to the 4th minus 1n to the 4th, which is 6n to the 4th. So I'm done with those. And then there's no cube term, so I'm going to go to square terms. So negative 3n squared plus 2n squared. 2 minus 3 is negative 1n squared, or just negative n squared, so I can write that. Probably better practice to just write negative n squared. And then 2 plus 5 is 7, and we're done. So that's equal to the last line, and that's equal to the last line. And same thing here. So really that is it. That is adding and subtracting polynomials. So I hope that video helps. I'll go ahead and post that. So I hope that makes sense. Just making sure that you guys have enough practice, and for those of you that are at home, or if you just need an extra refresher, there it is. So I hope that helps. Take it easy.